All right, welcome everyone. Appreciate everyone joining. Give everyone about a standard 2 minutes here to join before getting started. All right, I see a bunch more joining. So just to reiterate, I'm just gonna give about a standard 2 minutes here before getting started. We'll get started right away once the clock strikes. Appreciate everyone joining. All right, I think we're about ready to get going. So we are here to talk about firewall and security automation with Nautobot. Specifically, there's a plugin that Network to Code has been developing. I'll go quickly through the agenda and some logistics to get us started. So here's the agenda for the rest of the webinar. Current state of firewall management, Nautobot Firewall and security models overview, generating multi-vendor configurations with the Pirka and Nautobot, and getting started with Nautobot Firewall and security data models. Just a heads up, I think it was originally scheduled for 45 minutes. We're more than likely to go about an hour. This will be on YouTube if you cannot make it the full time, but just want to set expectations here at the top. So introductions, I am Ken Celenza, VP of Professional Services. I've been in the industry over 20 years, was a traditional network engineer who was always scripting in the background. About 6 years or so ago, I came over to Network to Code and kind of took those existing kind of programmatic scripting and network automation skills to become a full-time network automation engineer at that point, and been here ever since. With that, I'll allow Jeremy to introduce himself as well.
Hi, my name is Jeremy White. I am the Principal Developer Advocate for Network to Code. My past consisted of being on a network operations center, doing network engineering and incident management, and always kind of felt myself having repeated tasks, and I hate doing the same things over again. And so that kind of pushed me into the automation realm early on in my tech career, and it's given me the opportunity to have exposure to several very large, very interesting networks within my past, and how I've been able to help them on their road to standardization and reducing months to minutes.
Awesome. And Jeremy's the primary developer of the plugin or application that we're going to be reviewing today. Okay, just some quick notes. We have some upcoming webinars. The one we're at right now. In addition, at the end of the month, we'll be having a joint webinar with IP Fabric, and then simplifying network automation with Nautobot jobs on October 6th. All this information will be available to you in an email once we're complete, within the next day, I'll say. Jeremy, if you wouldn't mind, go over the with us.
Awesome, absolutely. So Network to Code has a super exciting announcement, and actually, this is the first place that you're getting this announcement. So this is a very awesome thing that we're going to be doing. Network to Code has always been focused on the community, and so we are running 2 separate events inside the month of October. We will be participating in Hacktoberfest, so we'll have full month long of Hacktoberfest going, and we're going to have different awards available, and it's mainly geared towards all contributions that are going to be within the Network to Code organization in GitHub and the Nautobot organization. No need to sign up on the Hacktoberfest. If you open a PR and it's accepted, it is considered a contribution and is considered part of Hacktoberfest. And the hackathon is going to be a dedicated 2-day event with presentations that'll be open for submissions a few days after that. And this is meant to foster the ability for Network to Code and the community to work hand in hand. For both events, we are actively going to be monitoring the Hacktoberfest 2022 Slack channel in our public community workspace. But we're also going to have the ability on those 2 days in October to have Network to Code engineers ready and standing by to actively jump in to help with code, help with bugs, jump into a dojo session and Zoom, and really try and make sure that we had this most collaborative experience to give everyone the best possible experience with working with Nautobot. If it's your first time doing open source, to I'm doing a super intense, very deep item for the hackathon. So super excited about that.
Awesome. And I believe there'll be a blog out here shortly as well, just to really go into details.
Absolutely. There will be a blog that will be coming out today. The blog will be treated as a live document. So as things get updated, the blog will be updated. The blog is pinned inside of the Slack channel whenever it is released, and the sign up is pinned inside the blog and the Slack channel. So all things that you'll need to know will be in the blog, and we will also be referencing that in the Slack channel. Thank you for the reminder, Ken.
Awesome. Thank you. Looking forward to it. Okay, and we have some training specifically around Nautobot training in November. There are 2 courses, Source of Truth and Nautobot Fundamentals, and Automating Nautobot with Python and Ansible. There's a sign up here, and for those that are watching, or will get the email shortly, there is a special code to get 20% off if you care to join. Okay, with that logistics away, we can get into talking about current state of firewall rule management. I have a fair amount of content to go through. I'm going to go fairly quickly. I want to make sure we have a bunch of time for the demos that we have prepared for you. Okay, so this is kind of something I've kind of written about before. It's like what I can guarantee, what I know about your current firewall process, right? There's plenty of reasons to add new firewall rules: zero trust, new data centers, applications, extended applications, etc. Configuration standards are not well known. You constantly see people, you could often tell the fingerprint of someone when they created a rule, how they name things, you use dashes or underscores, etc. There's really not even a good definition of what a good rule is, and that may vary between the different teams. A lot of these attempts at doing least privilege actually end up creating this Swiss cheese of security posture anyway. Requests are often filled in Excel with data that is not validated. So people put in IPs that don't exist, or domains that don't exist, or IPs that you don't own, et cetera, et cetera. Engineers don't know how their applications work, and application developers simply want it to work. And there's just kind of a miscommunication there for various reasons on that. Okay, so real quick, I won't read this for you, but this is kind of really based on a blog I produced, and will be linked in the resources at the end of the doc, at the end of the slide. But if you care to kind of get some more information around that'll be there for you. Okay, so some of the current state of firewall management. So some of the things that we're looking to attack as we're building out the firewall model plugin. First off, scale. We see a lot of Fortune 500 type customers with literally tens of thousands of rules, thousands of requests per year, and very difficult to reduce and easy to duplicate. Right. So a request is something I would often hear is a request is put in, and since we don't actually have the server, we're just going to make the request, and it may be there already. But nonetheless, the request is being put in, and no one has the capability to kind of understand that this is a duplicate request. Workflow, kind of mentioned this already, but there's multiple organizations involved, and configurations are not standardized, as various engineers have their own implementation or their own understanding of the implementation that they apply on there. Environment complexities, and these are just some of them: multi-vendor, multiple firewalls in path. We sometimes see 5, 6 different sets of firewalls in path. Ideally, no more than 1 or 2, but more realistically, this happens in highly regulated environments. And especially if you think of things like cloud infrastructure, Kubernetes. There could be actually different places of implementation that are beyond the firewall itself, right? There could be ACLs applied via IP tables or Kubernetes security, et cetera. Documentation, it's impossible to trace rule ownership. There is no documentation, for being honest yourself, and there's a lack of metadata to make decisions. We see this often, kind of within the audit, when doing an audit. Sometimes it could take organizations a year just to go through an audit, a successful audit, very manual, laborious tasks in doing so. Okay, so how does Nautobot firewall and security models come into place? Okay, so this is an open source Nautobot plugin or application that we have developed primarily by Jeremy here, and it helps plan and design for multi-vendor firewall rules, objects, and policies. The code is out there. You can get to it right now if you so desire. And it really helps define your security and policy intent, which goes in line with the current source of truth first that Nautobot has. Okay, so how does it work? From a very high level, we're gonna talk about it. You fill in forms within the Nautobot Firewall plugin. That populates the data model. Once you have the data model, there's a series of different things that you can do with that, such as programmatically interact with the API. You can query data. So you have, since it's all based, since the underlying infrastructure is based on SQL, you have that entire, and further exposed via Django ORM, you have that entire query language, which is really powerful for having one centralized place to develop those queries for interesting things that you may not think of now, but in the future, you can come back to and build that query then as the use case comes. Probably more interesting, and as we look at the arrows, we're outbound, we can generate configuration, which is going to be super important. And we're going to talk about Kapirka a bunch, and we're going to introduce that as well. But we use that to generate configurations from the model in your configuration management strategy. And then you could just view and investigate, right? And this is an actual screenshot from the UI, the Nautobot UI of the model. And you'll see it looks pretty familiar to what you would expect in a standard firewall rule product. Okay, so how do we attack scale? Reuse, right? So we can understand security rules, objects, and groups can be reused because we have, again, we could build out those queries. It follows much more of a write once, use many operational flow. We can find duplicates or existing rules, right? Having a model allows the security rules to be queried. And you could say, does this rule exist? Is this a duplicate? And you can build those queries across your entire fleet of infrastructure. So that may say something to the effect of, you have a firewall rule going through multiple firewalls, but maybe the first or third, or last firewall does not actually require it to be updated because that policy is already permitted. It's enforced elsewhere, but you don't have to duplicate that rule, or you can understand that these rules already exist. Rule compression, I think this is a great use case. You can apply business logic to rules to find if there's places of compression. So if you think of like, okay, if I'm going to add every time a new device is added, I'm going to add it to standard syslog, SCP type stuff. You could just you could build custom logic to say, okay, when I receive a rule that fits these characteristics, I'm just going to update this address group object rather than create a new rule, which we often see. So how do we attack workflow issues with this application? Standard configurations, right? We talk about that a lot, right? So move configurations to be an artifact of the model, not the configuration to be the actual state. Enforce all configurations generated by the model and report on non-compliant configurations. So if I have a source of truth and I can regenerate the configurations at any time, I can understand if they are standard configurations or not, because they should equal to what I would generate today, regardless if they were pushed yesterday. Reduce complexity and reduce human errors, right? So providing a simplified interface, such as a request form, reduce human interaction in general with the entire flow. I think we all can understand that. Providing that programmatic interface, right? So providing a data model or data structures that's the native interface for programming, right? So if you're going to interact and you're going to automate this, you almost always want, it's only feasible, I would say, to have a proper data model, especially with complexities that are introduced with the sheer scale of firewall rules in general. Okay, how do we attack some of those environmental complexities? Path analysis, provides foundation to build queries to find the path of firewalls. When we see these environments in which there's, like I said, ideally there's only 1 to 2 firewalls in line, but in many cases there may be much more, and it might not just be firewalls as well, right? It may be things like, as aforementioned, AWS security groups, or Kubernetes enforcing, or IP tables. There can be a lot of different places where security is applied, which complicates it and provides more devices to understand and traverse. A single model to multi-vendor and multi-cloud environments. So it provides the same interface regardless of edge technology's vendor. And I'm going to demonstrate some of that later, because there's obviously differences in how different vendors. So how do we handle that? And I think we've come up with some unique ways to kind of address those challenges. Perfect. And then rule and object splitting, right? So that kind of goes a bit before to what I was mentioning about applying some of that compression logic. Right now, generally speaking, we can't understand when a rule is created. Generally speaking, you can kind of assign an owner, or you can put something in the description there, but it's very difficult to get granularity beyond that because you can't, you don't have like the mechanism, you don't have the enriched data on all of these objects, right? So you can't say this address group object is owned by multiple people because there's multiple different addresses, right? More realistically, most organizations I've seen don't get below policy level ownership. And if I'm being honest, most organizations don't do actual proper ownership in general. Awesome. So attacking documentation. So ownership, that's going to be one of the components of it right off the bat. So it's, as I just mentioned, adding ownership to not only the security rules, but the objects and groups of security rules can be assigned into owners. We could have owners assigned to them. And this will, as mentioned, this allows ownership to be split within any object, right? Which is kind of unique. I've not really seen many organizations getting down to that level of granularity, which again goes into that duplication of rules. Because if I want to keep a structured ownership, I have to just duplicate my rules a bit. And rather than just add to an address group object, I'll just create another rule, which is basically the same thing with the additional address object added. Metadata, right? And so one of those pieces of metadata would be ownership, but there's just limitless amounts of metadata that can be assigned. Normally what I see now is people stuffing information into the description, and that never scales. It's not structured data. People have misinterpretation of what the proper parsing strategy is for that description, and it just kind of falls apart in general. Okay, auditing. So once you have that metadata, you can just build queries to essentially understand and enforce that audit criteria, and you can understand, do you have ownership? Do you have redundant rules, et cetera, et cetera? Okay, so that was really kind of understanding some of all of the things that we went around to the existing way things work and how we try to attack this. But if we just kind of take a step back and say, what are just some of the bonus benefits? Fundamentally, we believe source of truth first automation, right? And so having that proper separation of intended versus actual, having, that enables multi-vendor, multi-cloud, security and planning. But all the things that you would hear from any time you would use a source of truth first strategy, this helps specifically with the firewall and security models. Relationships and queryability. So by having it within Nautobot, you don't just have access to the firewall rule or security model database, you also can understand how that relates to everything else. How does that rule relate to a site, to a region, to a network interface, to an IPAM, et cetera, right? And so it's not just knowing one location, it's knowing how it relates and integrates to the rest of your ecosystem. And again, you have that programmatic interface via REST API, GraphQL, or Django ORM for all those various different use cases. And infrastructure as code, so building process that integrates with your infrastructure code ecosystem using Nautobot. There's many different extensibility options such as config context, jobs, custom fields, computed fields, all these new and different fun things that can be integrated quickly rather than have to go back to the drawing board and regenerate or build your data model, or getting to code. You could do things right in the UI and have updates nearly instantly. Okay, so what do security models and ACLs in Nautobot look like? First, I'm going to start with some taxonomy. We chose to use Palo Alto, right? So this is not, this is just kind of using their terminology to better relate and understand what we're speaking about. The terms are not that far off, but we just want to, for clarity purposes, just kind of show that. So first thing we talk about is objects, right? So we're using the same term. And this could be address objects, application, objects, zone objects, whatever those different service objects, whatever those different objects are, we use the same kind of terminology. Next is policy rules, would be kind of security policy rules within the Palo Alto ecosystem, but that's essentially a single rule that's applied. Okay. And then finally, or not finally, but next policy is just kind of a security policy, right? So all of the rules that make up your entire security policy stitched together in an ordered list, right? It's first match. So if it's allowed or denied first, that will be applied. And then we have a signed policy. So this is kind of like if you're used to Palo Alto's Panorama, where you can have device group policies, where you apply and you flatten various different device groups to be one policy that gets rendered on the final firewall, right? So that provides capabilities to reuse firewall rules, right? You can apply it once for a region or for all of your data centers and kind of build and stitch together properly, right? So there's actually a lot of interesting stuff going on here in ordering and in general to help with that scalability. All right, so this is a very high level, and I'm going to show you very briefly the low level as well. But this is kind of very high level of what the data model looks like. So on a high level, we have a policy, as just mentioned, each policy rule, and each policy rule is made up of various different objects. Now, most of them, the objects are all within the data model. Some of them relate to other data models, such as IPAM, which would be a core Nautobot data model, whereas FQDN would be a model introduced specifically just for firewall models, right? So there's kind of two different use cases, but they all act the same way. As mentioned, we can apply the policies to devices, or there is this concept of Nautobot dynamic groups, which basically says, based on the metadata or attributes of the devices, you can register yourself to that dynamic group, such as in what we'll show in the demo. We say North Texas. If you're part of the North Texas region, you automatically get added to this dynamic group. And just by adjusting the dynamic group, you subscribe or remove from all the various rules. This is a very simplified version of what's actually happening. We're not showing things like user zones, custom attributes, and other objects, or actions, logs, tags. It's much more. There's much more to it. So much more that it looks like this. But I am not going to belabor this. This is on our public GitHub repo for those interested in really getting to the nitty-gritty of the details. But there is a well thought of data model with a published UML diagram. And with that, I'm going to stop sharing and hand it over to Jeremy.
All right, so now let's get into the Nautobot UI demo. So we talked about having that centralized way of managing items and seeing the ability to how a policy can be applied on a device, site, region, what's the impact on all the underlying objects, and what value and everything that comes in together with. Just to hit again on terminology, for the UI demo, I'm going to be using the terminology that's native to the firewall models. So just kind of in the back of your mind, if I'm saying policy, we're calling that's essentially a security policy from the Palo Alto standpoint. If I'm saying a policy rule, that's a security policy rule from Palo Alto, or objects. And then from the Cisco ASA perspective, ACL is a single ACL would be the underlying policy, and then the lines in the ACL would be a policy rule. So let's get into it. So before we get into the weeds on how we are actually building and creating, I think it's best to first kind of start jumping through what it looks like to manage existing policies and objects. And so one of the first things that was very front of mind when developing the user interface is, how can I have this very clickable, expandable user interface that have the ability to see all this rich contextual data? So within that, let's jump over to my local instance. I've got a local instance running. I'll be showing you later on how to spin this up locally, but let's first start on how to use it. So one of the two things we're going to notice that are going to be different from the Nautobot homepage compared to what you probably have right now is we now have a new section called security, which we have inside of security nested our policies, our Kapirka policies, and our policy rules. And we also have a security menu item. So first, we're just going to be starting off with just our policy. And so let's take a peek at our policies. We'll see that we have policy 1, 2, and 3. Very useful descriptive information. It's probably as descriptive as my commit messages from previous lives. So let's jump into policy 3, because policy 3 has the most interesting stuff inside of the policy, but we'll jump back and look at policy 1 in a little bit to show some other information. So first, we'll see that we're assigning a dynamic group. So everything that, as Ken mentioned, that is able to dynamically get assigned via dynamic group is getting assigned this policy. And so if we take a look at this, we will have a simple dynamic group that just has a simple filter of site equals DFW. Nothing too crazy, but you can absolutely build your dynamic groups to think of it as like the API filter that we expose, or if you're in the device list view and you're wanting to filter down the devices that are returned, you can use that same filtering logic to limit the number of devices that would be exposed through the group. And then on this specific policy, we do not have any devices that are directly assigned. So all devices that have this policy are assigned through the dynamic group policy and not directly. So as we jump in and we are able to see all of the underlying objects that we have that are assigned to the policy itself, we can see the index for each rule in the policy. We'll see that we have our address groups and our address objects. I really have to say thank you, Ken, for taking the steps to add these nice little icons that helps with visualization. And everything is going to have a tooltip, which is kind of really neat as well. So if you mouse over a group, you'll see all the underlying objects in that group and how they relate. So it's very user rich. It's trying to expose the best usable interface as possible. And every underlying object, you can be able to click through and view that object and view the information in the underlying object. So if we wanted to continue to follow this chain all the way down, we'll get to our printer and then we'll see that we are just an IP address object. So this is kind of showcasing how we're able to utilize the existing items inside of Nautobot, show these relationships, and then expose an ability to query through UI, API, GraphQL, and ORM. So several different methodologies of being able to get the information and see how items may be applied. So we've got our nice policy, totally a real world, total perfect example. Yeah, and I'll get into exactly why I'm using this whenever I come back after I pass it back to Ken in just a moment. But we can see that this is a very descriptive way of us being able to build and describe all of our policies. So we've got our policies. I've already talked about the dynamic group portion. Now, how are these policies also assigned to the device? So let's kind of take a peek at that. So as I had mentioned on policy 3, we have a dynamic group that is assigned to policy 3. But if we go back to our policies, we'll see that we have on policy 1, we have both DFW and HOU that's assigned to policy 1, but policy 3 just has a dynamic group. So this is giving you the flexibility that as you're wanting to assign policies to underlying devices, that you can do it directly, that this device is the only, I want to make sure this always has it. it's perfectly fine. I'm going to do a static assertion to only that device. Or if you want to do things based off of grouping, so let's say I have all of my WAN edge routers that need to have this very specific ACL to prevent this very specific item. Cool. We can create a dynamic group based off of the device type and potentially site or location or some other descriptor to where that's the only item that shows up in that dynamic group. And we can create a policy that's assigned to that dynamic group. And as we build out and manage those policies, that specific policy could only be applied to that one to the set of devices that are associated with that dynamic group. So it gives you the flexibility to do direct assignment or inherited through that dynamic group. Dynamic groups came to Nautobot in version 1.2 and were further expanded in 1.4, and they provide a very rich and great way of creating these dynamic associations with our device objects. So, Ken hinted on this just a little bit ago. What happens whenever we update a downstream object? If, let's say, we have a object group and we add another object to that object group. Well, the way everything is built out, that is going to cascade upstream into the policy rules and policies that it's applied to. So if we come back over to our super realistic real world example, we'll go to policy rules expanded. I'm going to go to address group 1, which I think I have that open already. And I see I've got 2 address objects here. If I want to edit this, and I'm going to add another address object, and I'm going to add server, and then click update. So behind the scenes, so I've added this address to this address group. And if I come back to my policy and I refresh, and then I mouse over, we now see that that additional address object has now automatically been added into that policy itself, because this is all done dynamically through the Django relationships that are using to build the policies. So do keep in mind that all of these changes that can happen, they are live inside of the policy itself. And this gives us the ability to build and manage a intent-based configuration or intent-based state of the firewall policies itself, and how we can manage and push those out to our remote devices. And then, as I had mentioned, policy 1 has a little bit more interesting when it comes to assigning to devices. So we can see we've got HOU WAN 01 and DFW WAN on 1, but we do not have any dynamic groups. Let's go take a peek at the DFW device, because this also gives us a very interesting representation on how things are applied to a device itself. So these policies already exist, they're already created, they're already maintained, and through the use of template extensions inside of Nautobot, we're able to expose what policies are assigned to the device that you're specifically looking at. So on this view here for the DFW WAN device, we can see that we have policy 1 and 2 that are directly assigned, and then we also have a policy 3 that is getting assigned via the North Texas Dynamic Group. So it just gives us that additional flexibility to see how items are getting applied to our devices and what that may look like. And just because I keep hitting this home, this is all about reusing the set of tooling that is exposed through Nautobot to reduces the barrier for entry and improves the visibility to a network engineer and the organization on how items are built and managed. And one of the key things on that, and Ken did hit on that, is deduplication. And so giving the ability to have an easy way to filter and search and look up underlying objects or rules reduces the chance of you accidentally creating the same exact object or same rule, just a little bit different, because you can essentially fingerprint each object and rule to a lot of your underlying security engineers. You have no idea how many times I've seen 20 different permutations of HTTPS 443 TCP, because they're all different ways of doing capital case, lowercase, all those different variations of that. And all of the tooling that's built inside of this is to help with that deduplication of those objects, the rules, and really improve the management of your firewall policies. So Ken has already hit on, we are using Compirica, which is going to be a very robust tooling that is exposed by Google. And so what we are doing is that we have all of our data modeling that is housed inside of Nautobot. This is our our opinionated vendor abstracted data model that is leveraging the built-in objects within Nautobot. And what we do is that we translate the data model from Nautobot into a set of objects for Kapirka. And these are, I believe they're actually referred to as Kapirka files. And so we have our networks, our services, and our policies. And there is a full representation on how each one of these translates on the read the docs for this repository. So it gives a more in-depth detail view on that. And then we take all of these dynamically generated versions of the Nautobot objects into Kapirka, and the Kapirka is able to take those files, those objects that it's being able to source as its own opinionated language, and translate them into device-specific configuration. So we have our Juniper network configuration, our Palo Alto, and our ASA. And of course, these are truncated. There's no, and not necessarily meant to dive into the deep of it, but these are actual representations of configurations that were generated by Kapirka using the Firewall Models plugin. So how do we generate a configuration for a device inside of the Firewall Model plugin? There's a couple different ways that we should be able to do this. We should be able to go to Jobs, and inside of the Jobs menu, I'm going to be going to the Kapirka job itself. Then I'm going to specify the underlying devices that I'm going to care about. We will be we will take some time to also evaluate other methodologies of exposing more filters and more items. Right now, the Jobs is based off of a per device generation. So I'll click on the Generate Firewall Config via Kapirka. We'll click Run, and then let's go ahead and specify our DFW WAN and our HOU WAN devices, and click Run. And this is a very quick job that's running behind the scenes to generate the configuration. I feel like I skipped over. Nope, I come back to that later. Okay, cool. And so now if we go to our DFW WAN device and we take a look, we now see that we have a new template extension that exists. So if we click on this template extension, we'll see the actual generated config for that device so that it can be directly applied for the policy on the remote device. We also have we've also exposed the Kapirka objects, or the Kapirka files, I guess is a better representation of it, to showcase how these get translated. So we're translating from our opinionated abstracted level to Kapirka's opinionated abstract level, and then that gets templated out into the device configuration. So we have our policy, we have our networks, and we have our services. So we're not going to get in super deep on what the weeds are on those, but this kind of understanding that the job itself will dynamically create those for you based off of the policies that are assigned to the device and how those policies are constructed. All right, so I actually kind of breezed through and did 2 bullets at one time. So let's jump into creating a policy. So first thing we're going to need to do is let's go ahead and just create a shell of a policy. And for this, we're going to navigate to the policies list view, or we can do it directly from the drop-down menu. So I'm actually just going to do it directly from the drop-down menu. So I'm going to call this webinar demo. I do not technically have any policies that are actually, I'm going to assign a policy, a policy rule. I'm going to assign policy rule 1, and I'm going to assign our implicit denial all at the end. Not a big deal. And then I'm also, just for grins, going to assign it to the North Texas dynamic group. So essentially all that we've done so far with this is that we have a very generic policy that has the same policy rule 1, that has the same address groups and everything that we have previously, and then the implicit deny all at the end. I've assigned, and I very quickly skimmed over that. I did assign the policy to the North Texas group, so that is now going to dynamically get applied to anything that matches that dynamic group of North Texas. And then next, we're going to be going through and introspecting the objects and groups that we may be using. So let's go ahead and create a address object and a address object group. Because for the rest of them, because we already have a lot of these that are already existing, that it's not necessarily needing for them to be created. So we'll come into security, we'll go to address object, let's do an IP range, and we'll do a start address of 10.0.0.1, and we will do a ending address of 10.0.0.10, and we'll go ahead and create that. Now let's take this address object that has been, I'm sorry, this is actually not even an address object just yet. Because of the different types of address objects that exist, we have the upstream address object, which is the IP address, prefix, FQD, and our IP range. And then those have to be added to an address object, and then we can consume them inside of the policy. So we'll create this, and we'll call this Jeremy Home Infra. If I could type, and I'm going to grab my IP range, status is active, and we'll go ahead and create that. I think we're going to skip the address group just to kind of, for the sake of time, let's create the policy rule. Home infra to inet. So we're going to do a index of 20 because I have a index in there already. Just out of knowledge from running through this demo a few times, an index of 10 and an index of 100. So our first policy rule that was already in there is an index of 20. We're creating one that it's an index, first one that's in there is an index of 10. We're creating one of an index of 20. And then we're going to add our objects to it. So we're not necessarily going to be doing anything with users for this. We can do a source group, so Jeremy Home Infra. We'll do a source, actually this is going to be sourcing from LAN. We're not going to specify any type of a service object because I don't care about my, my initial port definition, so the source port. I'm only going to be caring about the destination port. So we're going to specify that our destination address is going, let's do server. Our destination is going to be into the DMZ. Yep. And our service objects, we are going to care about HTTPS, HTTP, HTTPS dev, and is there any other fun ones that we might need? No, I think that this is all that we are, I will do HTTP dev. So cool. So we're just basically specifying this. These are the allowed ports that we're going to be communicating on, and we're going to allow that. Filter request identifier, so we can say this is request ID 456123789. So this is an item that can be tracked back to a ITSM ticket, be it in ServiceNow, BMC Remedy, or whatever that underlying ticketing system may be. We've created our policy rule. Now let's jump back over to our policies. We'll go to our webinar demo, edit our demo, and we can add our policy rule that is going to be home infra to inet with the request ID. And then we can hit update. Now if we come and take a look at policy rule expanded, I have a bug in my local system I haven't had a chance to push out just yet to resolve this, but we can see that we have our policy rules, we have the appropriate indexes, and we have all the appropriate information. And if I jump here back over to jobs and I generate, I have not tested this generation, so please hope the demo gods are smiling down on me. And of course, I did not do it. Kapirka does not support IP range. That's absolutely correct. So let's jump over, and I will quickly throw in a different IP address. I'll do a slash 28. Just to quickly get this out. And we can very quickly see that, oh my goodness, I don't have a compatible item. And the IP range is something that is supported by some underlying systems, but not all. And so we can see that Kapirka does not directly support that. I'm going to come back over to my address object, Jeremy Infra. I'm going to edit this. I'm going to remove my IP range. And I am going to swap out for the 10.0.0/28 that I just created. I hit update, and then I come back over to jobs and I generate my configuration, and this is expected. And of course, demo gods are going to be screaming at me. Fun time. So give me half a second.
And while Jeremy is reviewing that, there's actually a lot of effort put into kind of mapping out, like as mentioned, there's a compare opinionated model, and we have our opinionated model. So where they overlap, we just naturally use it, and where they don't, we try to give sane error messages like that, which is, hey, specifically this IP range is not supported, FQDN is not supported by Compirica. Just if those are features, there are ways around it. It's I mentioned in the chat as well. I just call it bring your own code, BYOC. So those capabilities are there to enable those, but you have to roll your own a little bit more. Ideally, things work, just natively with Compirica, and many organizations are using Compirica already. So ideally, or obviously, there's been success so far with it.
May have to restart my worker also.
And there's a question asked as well. Yeah, is there a policy holder? Yes, absolutely. There's actually kind of many different ways of handling it. It's a bit complex to fully cover here, but they have been alluded to already by Jeremy in terms of you have the ability to add indexes from policy rules in a policy, as well as you can stitch together different policies with weights. That's what Jeremy was showing with weights. So if you combine those two, you really have an endless amount, but it does, like, you probably need to play around with it to understand what that means. There's just probably some new terms to it, and everything. So
cool. Looks like my database is not becoming happy, which is perfectly fine. And for the sake of time, I'm not going to do live troubleshooting. No one ever wants to see that. So at this point, I'm going to kick back over to Ken. We'll talk about multi-vendor firewall generation.
Awesome. Thank you, Jeremy. I'm going to share my screen. Okay. So as mentioned, generating multi-vendor firewall configs. And so I just have two quick slides here, and I will jump into the demo itself. So the first one we're going to do is we're going to change vendors here. We're going to show you how kind of easy it is, right? And you're going to ask yourself the next question, which is, but hold on a second. There are obviously differences between these firewall vendors. How do we kind of account for those, right? So I'm going to jump in to that. And as mentioned, we're going to go from Juniper to ASA to Palo, and I'm on my local instance here. So right now, if we view, just as Jeremy had shown, it's in the same layout, obviously. I must have, okay, so I cheated. So I will rerun this now. I must have, when I left this, I left it in the current state, which was me going through that run. So as we see now, okay, so now it's based on Juniper configurations. And the reason it is because we have our platform set to Juniper, right? And we have our device type and manufacturer as well, all kind of set to Juniper. But what I'm going to do is I'm going to cheat a little bit, and I'm just going to change the platform. So in the interest of time, I'm just going to change the platform and keep the device type. But this is important to note that our Compirica integration is keying off directly off the Cisco ASA, or sorry, directly off the platform, which is Cisco ASA. So now when I update this, I can go, we have a convenience button right here to say, execute this job in Compirica. And I go and run that job, regenerate the configurations. And through through magic or programming, when I refresh, I will now get the Cisco ASA configurations, right? So awesome, right? So we can quickly change from vendor to vendor, presuming we have the proper data model already. Let's take that one step further, and let's change it to Palo Alto. Okay. Awesome. And I'm going to do the same thing again. Again, so our computer firewall configurations here. I have this convenience button. I'm going to click that. I'm going to rerun this job on this device. And yet again, through the power of magic or programming, when I refresh, I will get the Palo configurations. All right, awesome. I think that's pretty cool, pretty powerful to show what having a centralized data model can do for your environment. But there's some obvious issues with that, right? So Palo, as an example, has App ID, and most firewall or most vendors, IP tables or similar, AWS security groups obviously don't have App ID. So how do I apply the same policy when there's different feature sets allowed? All right, it is a non-trivial issue, so there's a non-trivial solution here. Nonetheless, it is, I believe, well documented here what the process is. At a high level, what you're saying is you are allowed to provide these terms or headers. So CTD, right here. You're allowed to apply Kapirka header data or Kapirka term data. Now, these are super specific. I'm not going to bore you with the details of it, but nonetheless, it's well documented by Google's Kapirka library, what header data is versus term data. You allow them, and then you apply a custom field to your platform. So we're going to show that now. And I have already set this up to apply in Palo Alto's platform a specific custom field to say you can allow these different terms, CTD, so Kapirka term data for PAN application and expiration, right? These are unique to the Palo's implementation using Kapirka's terminology. So we have yet another custom field that gets applied to the policy rule. So what I'm going to do here is I will set this up. I guess I left this as well, but I am going to add this custom field for GitHub, right? And this is whatever application ID, if it was Facebook or whatever, social apps, whatever the specific application ID is, you can apply that to this rule, and it would automatically get implemented. Okay, so we will update that. We will once again, we're back at our primary firewall that we've been working on. We will once again run this. And I'm going to jump, we have some convenience methods here as well to find your way back to that device. Review the configuration applied. And lo and behold, we have GitHub there. Okay, so the last thing will be is to show if we bring it back all the way back to Juniper and rerun the process, we will have no mention of GitHub. So this is platform specific. We've created a way to expose this so that you can have platform specific options. So yet again, we will run the job. And when we refresh here and we search for GitHub, we sure enough find no results. So I will pause there. I believe that's pretty powerful. It is it's a complicated problem, so that it comes with a little bit of complexity in the overall solution. I will at this point hand it over to Jeremy to continue on.
Absolutely. So we've gone through, we've talked about how to use the UI, we've talked about the power of Kapirka and being able to generate device configurations and be able to see all these relationships with the object, with the policies into our underlying infrastructure or sites or regions. So now, how do I get started? How do I have a development environment? How can I test this out? How can I kick the tires? And that's what we're going to be talking about now. So getting started with firewall models. So the development environment is something that is super simple and very easy for you to get set up in a very, very short period of time. The development environment is going to match the same type of development environment that you will see for most of our Nautobot apps and the core components of Nautobot itself. It's made up of our Nautobot instance, a Celery worker, a Redis queue, and a backend database. And these are all orchestrated behind the scenes with Docker. Now, it's a little bit more than just orchestrating with Docker. So we do use an extra set of tools. So we use a Python package called invoke. So if you're familiar with make files on traditional Linux systems, think of taking a make file, but doing it in a Pythonic manner to try and help out your development process. And I've structured this into 3 major buckets. So for requirements and dependency management, we really found that doing dependency mapping, package building, and everything, the best tool that we've come across that's been very successful has been Python Poetry. Very, very well documented. It's something that I went kicking and screaming into when we first started using it, but after I actually started using it, and instead of fighting poetry, using poetry. And what I mean by fighting poetry is I would always get annoyed and I would just go straight to pyproject.toml and I would update it, and that's where you're going to have a bad time. So always interacting with poetry with its native commands and everything, and it does a phenomenal job for dependency management and dependency resolution. And so you start kicking out some of the issues that you may have had previously within just doing traditional setup.py and pip installer requirements txt. So cool, we have our dependency management now. How are we standing up all this infrastructure? Am I running several different Docker commands, and I've got a command that's a mile long, and all of that is invoke running that mile long command for me? The answer is we are using Docker Compose to be able to build and deploy a local environment on your system. And I just realized I have a step that's missing inside of the slide. I will talk through that step and I will show said step. So Docker Compose is actually a orchestrated way of defining your interactions with containers as code so that you can be able to spin up specific services, expose east-west communication based off a name resolution for the service, and not have to know the IP address for each underlying container or service itself. And then lastly, I'm going to show you how we are able to deploy demo data directly into your development instance of Nautobot with firewall models installed. Because for me, I know personally, it makes it a lot easier if I'm coming into a net new tool or net new something, if I can spin up a development environment that has some level of information already there and already populated, it makes it easier for me to be able to follow what I'm going through. So as we can see, we've got 5 underlying steps here on the screen. We're missing one step. And that one step is going to be in the README MD, and I'm going to show you that as I do it. So first, we're going to do a git clone of the repository. Before I do my invoke build, I'm going to copy the example credentials into a separate env file. This is something that we do as a pattern within all of our development environments because there are things like secret keys or napalm credentials or other underlying secrets that we should treat them as secrets. Even though this is a development environment, we still give the ability to treat those as secrets, and that new file we create is not tracked by Git. And that's why we provide an example of what we expect in that file. So you just do a CP of the original file to destination, and it will do it. After we do that, we're going to perform an invoke build. That's going to trigger all of the building of the Docker containers behind the scenes, so you don't have to know or understand that actual Docker interaction or constructing a Docker file. I personally, this is not a requirement, but I personally like using migrate and start separate in my development environments because of test data. And the reason behind that is so invoke start will migrate for you. But if I'm waiting to inject test data, I can't inject my test data until all of my migrations are finished. So I like to do my invoke migration first, then start. That's just a personal preference, not required. Then lastly will be the test data. So if we jump over here, now back at the same URL pattern. Yes, sir.
Maybe in the interest of time, we move to Q&A. I think you have it well documented for the steps, but we're about at an hour anyway.
Sounds good.
Want to go
So
to the
Q&A.
resource slide? Yeah. So any questions? I'm just answering one in the background right now, but just want to leave it open for any questions that anyone may have.
Does it make sense to combine iRoute file plugin with that? Your typical trademark. It depends.
Yeah. So the question was, does it make sense to combine Nautobot Firewall plugin with Tufin? And I would say it depends. I wouldn't say it certainly it doesn't replace all the functionality, for Tufin, or even intends to. But if you're on your network automation journey and you're kind of building, a lot of your own tooling on top of open source software, it's certainly a foundation for much of that. But if you were to go feature by feature, there is not a tremendous amount of overlap in terms of feature capabilities.
And Jason's made a great point. SSOT integration could be an awesome option for integrations with tools like Tufin or other orchestration tools for the actual push out to the remote devices and how that is managed. If you're not familiar with SSOT, it's a framework that is built on another package that NTC manages called diffsync, which gives you the ability to take two disaggregated sources that may not have the same schema and create a translation layer to where you can essentially ETL from one source to the next.
Okay, next question. What if you're managing Palo Alto firewalls through Panorama? I would say it certainly, Panorama certainly simplifies many of these things. So, just having one place to interact with to push all of your configurations. And, it really comes down to, do you want to separate your intended state from your actual state, right? And there's all the advantages that go with a source of truth first automation strategy. That to me is kind of the crux of any of those questions that would be had. Yeah, just understanding the relationship between infrastructure code and source of truth and how it relates, right? Just because something is configured a way, should it be configured that way? But obviously Panorama helps tremendously to just have one API to interact with to deploy your entire fleet of infrastructure. Regardless if it's going direct to a device, you can still go through the Panorama, or if it's going to your device groups and applying policies that way as well.
Absolutely, and because of how verbose and how easy to use the Panorama API and the Panos API in general is, I can see that also being another use case of being able to enrich with SSOT as well. So defining a separate SSOT job, you may have to create a separate translation layer. So maybe not going from Kapirka to Panorama. You may have to go from firewall models to Panorama and in that order. But SSOT, I think, could also help with that as well.
Yeah, one resource I'm realizing now we forgot to put on here is demo.nautobot.com. This is actually live as of this morning. So we weren't as we did not know if it's going to be live, and so it is. But now you have access to this. Awesome. So you can play around with it right now and kind of see how it works and feels and this and that. So looking forward to getting feedback as that, and looking forward to providing the opportunity to people to right away instantly kind of test this framework out.
We will also be in the coming weeks adding additional demo data into the plugin inside of demo.nautobot. Right now, the plugin data is initially built off of the test data. So we will be enriching that data as the days go by. So if it looks just like it did whenever we did the demo today, come back in maybe a week or so, and you'll see that as it progresses, we're going to be adding more and more information into it. We are also been very responsive to bugs and reports within Slack. We really want to make sure that this is a app that gets as much adoption as possible. It was initially developed in a silo over the weekend. I got a harebrained idea, and we have destroyed and rebuilt the data model. I have no idea how many times, but I'm super excited to see how it's progressed. And I really feel the best way for us to progress to that next level is from community feedback and where the community sees it, because I can develop it in my tunnel vision eyes or Ken in his tunnel vision eyes, but we want to make sure that from a community perspective, are there use cases that maybe we focus too much on, or is there use cases that you want to see more of? We are going to be focusing more on some updates within the UI to kind of help with that usability and the ability to ingest an existing policy to try and help lower that barrier for entry. We also have a feature that's in development right now by one of our colleagues, Leo, that is working on adding NAT models into the firewall plugin as well.
Awesome. Thank you, Jeremy. I think we could wrap it up. I don't see any other questions coming into it. Appreciate your time. Appreciate everyone joining. Thanks, everyone.
Awesome. Thank you.